Hey guys, so we're on page 64 of your student journal, starting section 3.2, linear functions. How can you determine whether a function is linear or nonlinear? So that question is really just asking you, how can you tell the difference between something that's a line and something that's not a line? So in a picture, it's very simple, right? But in other representations, it's not always that simple. And in fact, I'll actually go back. So we can look at, oh no, it's later. Okay. So there are going to be a lot of representations, I think 5 different representations for functions. And so it can be, they're not all pictures, so it's not all that easy to tell. A linear function, a function where as x is increasing, let's just say as x is increasing or changing constantly, so does y. So what does that mean? For example, if I start off with 1 and 5, and then I go 2, then 8, and then I go 3, then 11, you should see a pattern here. Each x is going up by 1, so that's a consistent or constant pattern. Each y is moving up by 3. That too is also a constant. Another example might be, let's start at 10 and go 16, and we'll say 8 and 12, and then 10, 8, 6, 16, 12, 8. So what is happening here? 10 is going down by 4, and so x is going down by 2, so 10 minus 2 is 8, 8 minus 2 is 6. But as this is happening, the y is also changing at a constant rate. So 16 minus 4 is 12, 12 minus 4 is 8. So the x's and the y's don't have to change at the same rate in relation with each other, but the x's in relation to each other have to change at the same rate, and so do the y's. So even though the definition for linear function says as x is increasing constantly, really that should say changing. So I will fix that here. Changing. It doesn't have to be increasing, it could be decreasing as well. A nonlinear function is exactly what it sounds like, especially after having defined linear. A function where this constant is non-existent. So a function where x is changing constantly, but y does not as well. So y may not be. For instance, let's say 1, 5, again, 2, 8. So each x is going up by 1, but it said my y's first went up by 3, and let's now put it up by 4. Well, now it's different, so that does not count as, or this counts as nonlinear function. Another one might be, let's just go back to our, let's say 10, let's say 20. Let's just go up by ones. And we'll say, nope, they both went up by 1, and the x went up by another 1, except this became 14,019. Well, that doesn't make any sense. The x went up by 1s each time, and the y went up by 1, and then the y went up by a little less than 14,000. So it doesn't make any sense. Okay, that's those definitions. I can erase those, and we're going to go down. Solution of a linear equation in 2 variables. So if you look at this tab, I have defined discrete versus continuous. I needed to remind myself how I could define it for you guys. This I did not look up, but the gist of it is an ordered pair for a function. Sorry, that should say a valid ordered pair for a function. So what does that mean? Let's say our function is, e.g. means, for example, y equals 2x. That means if I plug in x equals 5, then I will get y equals 2 times 5. So our input is 5 because that's x, and our output is 10 because that's y. So this is a solution, 5 and 10, because if I plug in 5, I get 10. What? This is not valid if I say 5 and 15. Well, 2 times 5 is not 15, so that does not work. Okay, so discrete is when a discrete domain, so again, domain meaning x, is when a discrete domain, when the domain consists solely of integers. So things like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, those all work. What's the difference between that and continuous then? A domain that consists of integers and the values between them. For example, 1.1, 1.1, 1.2, 1.3, 1.4, whereas discrete would be 1, 2, 3, 4. Okay, so discrete is integers only, continuous is integers and everything in between. Okay, and with all that said, finally I think we can move on to some stuff. So here are your 5 representations. These are all the same thing. You're looking at 5 different representations of the same thing. So we have a function, an output, so an output y. I'll remind you, an output is 3 more than the input. So whatever number this is, y, whatever number x is, y has to be 3 bigger than. So 2 is 3 greater than -1, 3 is greater than 0 by 3, 4 is greater than 1 by 3, 5 is greater than 2 by 3. If you look at this, we have a clear one-to-one design, which makes it a function that makes sense. And again, on a graph, you take any point, you add 3. You take any x, you add 3. So if this is 1, you got to take 1, you got to add 3. If this is 2, you got to take 2 and add 3. If this is 3, you got to take 3 and add 3, right? So you have all these different representations of it. The student journal is kind of lacking in this, in that there are 5 representations, but since there's such a limited space, then we're not going to cover all those in depth. Discrete and continuous domains. Here are examples: integers from 1 to 5, integers only. Continuous is all numbers, including 1.1, 1.2, 2.0001, and so on and so forth. So discrete is distinct individual numbers. Continuous is everything in between. Determine whether the graph represents a linear or nonlinear function. Basically, it's asking you if it looks like a line. So what do you guys think? Does number 1 look like a line? No, it's not a straight line. Then we can move on over here and say, oh, yes, it is a straight line. So, wow, there that is. It's straight. As x is going up, it's going up by the same amount. Here, there's like a fairly big jump, but then as you go further along, the increases get smaller. It plateaus, right? So it's not constant. Constant meaning like the same or consistent. Okay, so let's look at our x's. What's happening here? X is just adding 1, adding 1, adding 1. What's important is that this, is consistent. Then we have plus 3, and plus 3. Yep, that works as well. So this is a linear function. As the x and y, the x's and y's are changing consistently relative to each other, x's to x's and y's to y's. Next, again, this is going up by 1. The x's are going up by 1. And there we have going down by 1. Oh, but then we have up by 1. And then we have up by 3. There is no consistency there. That's a nonlinear function. There's no consistency in the increase or decrease. Okay. Here, there's a number of ways to do this. What will I do? I will choose to make some ordered pairs. So if you plug in some numbers, for instance 0, 0 represents x, so 2 times 0 is 0, 3 minus 0 is 3. Let's see here, 1, 3 minus 2 times 1 is 1. And lastly 2, 2 times 2 is 4, so 3 minus 4 is negative 1. So let's see here. Our x's are increasing by 1, 0 to 1, 1 to 2, and then our y's are decreasing by 2. And as long as they're the same across, then we're good. This is the same as that, and up here you add 1, you add 1, that is the same. It's all good. I don't know why this is a poor example, because some of you guys are not sure how to cube. But a cube is when you just multiply something by itself 3 times. And in any case, I'll do another set of ordered pairs and see where this takes us. So 0 times anything is going to be 0. And then 1. 1 times 1 times 1 is 1, times negative 3/4 is negative 3/4, or negative 0.75. And then 2 times 2 times 2 is 8. 8 times negative 3 is negative 24. Negative 24 divided by 4 is negative 6. So here our x's are changing consistently, adding by 1, adding by 1. So right now it looks like this is linear, and we have down by 0.75, and then we have down by 5.25, and now we can see this is not consistent, not linear, not linear. Okay, moving on to the next one. This is just remembering a definition. Discrete, how do you remember that discrete things are separated? I honestly don't know, but continuous should make sense. Continuous, I guess you would consider as connected. Obviously, this line is connected, and that I would tie that to the definition for continuous connected. This one is separated. There is not one line to connect them. Then this must be discrete. So here I would say the function is continuous because the line is all connected, or sorry, the points are connected by one line. Here I would say the function is discrete, or sorry, the domain, sorry, I did not mean to say function, the domain. The domain, for those of you who are not listening and just watching, the domain is discrete because each point is separate, or is separate from each other. Alright guys, there we have it. Like I said, the student journal is kind of inadequate on this one. Definitely go into your books to practice distinguishing things like discrete, continuous, linear, nonlinear, function or not function. And if, as usual, if you have any questions, ask your teacher or let me know, and we can get those answered.